Well, finally we've arrived. We've been working with all of these roots and these radicals, and now we're going to finally deal with equations that have radicals. We have radical equations. How do we solve radical equations? So let's start with the simple ones to as complex as we'll get in this section, and it'll go a little bit fast, but I think you'll have an easy time of it. Here's an equation with a radical. 3 plus the square root of 2x minus 3 is equal to 8. Okay, step number 1, isolate the radical all by itself on one side of the equation, which means I need to move this 3 to the other side so that this radical will be isolated. It's added to this, so I'm going to subtract 3 from both sides, and that'll leave me with the square root of 2x minus 3 equals 5. Now, how do I get rid of the radical? How do I unroot? What's the inverse or the opposite of a square root? It's square. You undo a square root by squaring. And whatever we do to one side, we do to the other. So what we're going to do is we're just going to square both sides. So this squared and the square root cancel each other out. So you're left with just the radicand, which is 2x minus 3, equals 5 squared, which is 25. And now you just solve for x like normal. So, add 3 to both sides. 2x equals 28 and divide by 2, and x equals 14. And you could plug that in and check your answer to make sure you got it right. Here's another one. Another radical equation with a square root. So first isolate that. That means we need to move this 5 by adding 5 to both sides. Now in order to get rid of the square root or to invert the square root, we square both sides. Simplify that and now solve for x. 4x equals 24, x equals 6. And there you go. Now we have another equation that isn't a simple square root. We have an exponent here that's rational, so we have this expression x plus 1 being raised to the power of 2/3. How would we get rid of the 2/3? It sounds complicated, but once I show you how, it's really pretty easy. First thing is we need to isolate this radical. So start by dividing both sides by 3. Since it's being multiplied by 3, divide both sides by 3, so we get x plus 1 to the power of 2/3 is equal to 4. Now the way to get rid of this 2/3 is to get it to 1. And the way we get it to 1 is by multiplying it by its inverse. Multiply it by 3 over 2. Same thing with how we get rid of a fraction when it's a coefficient. We multiply by its inverse. Same thing with the power. We have this exponent of 2/3, multiply that by its inverse, 3 over 2, and this will become 6 over 6 over or 1, and we will have gotten rid of our exponent. But if I multiply this side by 3 over 2, I've got to do the same thing here. This has to be raised to the power of 3 over 2. So I have 2/3 times 2/3 is 6/6 or 1. And we have x plus 1 equals, and remember this is the root, this is the power. The square root of 4 is 2. 2 to the power of 3 is 8. Now, if you remember way back when we first started doing this stuff, we talked about when we needed absolute values. And so your book says this should be an absolute value so that there's 2 answers. And you may or may not remember that. Don't panic if you don't. If you just solve it like this and you get x equals 7, that's pretty good. So here's a similar type of problem, only it's written in radical form instead of exponential form, but we still go through the same process. If you want, you can change this to exponential form right away, or you can get rid of this stuff first and then do that. Doesn't really matter when. But let's isolate the radical. Let's subtract by 1 first. So we have this is x plus 1 cubed, and I'm subtracting 1, so this is 24. And then I'm going to divide by 3. So I'll divide by 3, and I get the 5th root of x plus 1 cubed is 8. Okay, now what I have then is I have this expression x plus 1. It has a root of 5 and an exponent of 3. So remember, the power over the root, this is to the power of 3/5. Now, to get rid of the power of 3/5, I multiply that. So I have a power of a power by its inverse, or I multiply that by 5/3. Both sides, 8 to the power of 5/3. And now this cancels each other out, and I'm left with x plus 1. And the cube root of 8 is 2. This is so nice that they have these numbers that work well. Cube root of 8 is 2, and 2 to the power of 5, 2, 4, 8, 16 is 32. 32. So x equals 31. Wow. Okay, you have an application word problem. This is how to measure the volume of a crater that's created by a meteor. And the diameter of that crater is 2 times the cube root of the volume divided by 0.3. That's the formula that you would use. So what they did is they measured the diameter of this crater, and they want you to figure out what the volume would be. If you look through the example in the book, they took this formula and they totally rearranged it and solved it for V first, and then they plugged in the number for the diameter. I'm just going to start by plugging in the diameter and then solve it. Their diameter is 1.2 kilometers, but this formula works for meters, not kilometers. So we have to change this to meters. 1.2 kilometers is 1,200 meters, or 1,200 meters. So D is going to be 1,200. So 1,200 equals this. There we go. So the first thing we're going to do is divide both sides by 2, because we want to isolate this radical. Now we have our cube root isolated. So the way to undo a cube root is to raise both sides to the power of 3. So this is going to become 600 to the power of 3, and this to the power of 3 is going to undo that cube root. So 600 to the power of 3 is 216 million. So the volume divided by 0.3 is this number. So to solve for volume, I just multiply both sides by 0.3. And I found my answer. The volume is 64,800,000, probably cubic meters, because it's a volume. I didn't check the units, but this was in meters, so I would assume that's cubic meters. That's a very large crater. So far, our problems have been relatively simple, believe it or not, because we've only had one variable on one side of the equation. But notice this equation now has an x, a variable in the radical, and the variable on the other side of the equation too. You're going to go through the same steps as you did before, but now squaring both sides is going to be more complicated, and you're going to need to check for extraneous solutions. So when I get to there, I'll explain to you what I mean by that. But first, we're going to isolate this radical by adding 5 to both sides. Now we have the square root of x plus 7 equals x plus 5. To get rid of that square root, we have to square both sides. This side squared will just be x plus 7 because we've gotten rid of the radical. But this has to be FOILed. This is not x squared plus 5 squared. This is x plus 5 times x plus 5. Please FOIL that. Don't forget. So this is equal to x squared plus 10x plus 25. And now we need to solve for x. So set it equal to 0, subtract x and subtract 7 from both sides, and we get 9x and 18. And now, are there numbers that multiply to be 18 and add up to 9? And there are, 6 and 3. So this factors to be x plus 6 times x plus 3, which means x is -3 and -6. Hopefully this is all good because we've been doing this for a while, right? The thing is at this point, because we squared the x, these numbers look like they could work, but they won't necessarily. You could have what's called an extraneous solution, a number that appears to work, but when we try to put it in the equation, it doesn't work. At this stage, you must check your answers to make sure that they are solutions. So let's check -3. If this is -3 and this is -3, then this is the square root of 4, or 2, is 2 minus 5, -3. Yes, -3 is a solution. Nice. Okay, what if x is -6? So we plug in -6 in both situations, -6 and -6. -6 plus 7 is square root of 1, so this is 1. 1 minus 5. 1 minus 5 is not -6. Sure enough, this one doesn't work. So we only have one solution, -3. Please don't forget to check, and don't forget to FOIL. Let me walk through that example one more time before I give you another case, even a more difficult kind of case situation. But let's walk through this again. Let's isolate the radical. We're going to subtract 3 from both sides. Now to undo the square root, we're going to square both sides. Notice I FOILed x minus 3 to get this quadratic, and these two canceled each other out, so I'm left with 5x minus 1. Now I'm going to solve the quadratic by setting it equal to 0. Now I'm going to hope that I can factor this, and I can. Two numbers that multiply to be +10 and add up to be -11 are -10 and -1. So this factors to be x minus 10, x minus 1. That means my solutions are +1 and +10. Last step, I must check because I could have extraneous. So one at a time in my original, all the way back in my original, I'm going to try 1 and try 10 to see if they work. If x is 1, then 5 minus 1 is 4. That's the square root of 4, which is 2. 2 plus 3 is 5, not 1. So 1 doesn't work. I can reject that. Now I hope 10 works or I didn't do it right. If x is 10, this is 50 minus 1, or the square root of 49, which is 7. Is 7 plus 3 10? Yes, 10 works, so that's my solution. Okay, here is the most challenging type of equation that you're going to be asked to solve. And this one involves two different radicals in the equation. What do you do when you have two radicals? So it's very similar to what you did before. What you're going to do though is if you have two radicals, first of all, if you have two radicals and no other number, like if this was 0, then you would have just added square root of x to both sides, and you would have gotten the square root of 2x plus 1 equals the square root of x, and just square both sides, which means 2x plus 1 equals x, and then solve for x. X equals like -1 or something. That's easy. Not a problem. If you have two square roots and just the two square roots or cube roots or whatever, put 1 on each side of the equal sign, square both sides, you're good to go. Unfortunately, this original equation wasn't so simple. So even though we have this 1 in here, we're still going to do a similar type of situation. We're going to make sure that the most complicated radical is left by itself, and we're going to take the simpler radical and put it with our whole number. So what we're going to end up with is the square root of 2x plus 1 is equal to 1 plus the square root of x, because we added square root of x to both sides. And now we're going to undo this radical by squaring both sides. I rewrote this to the square root of x plus 1 because I'm so used to binomials being variable plus number, and that just is better for me. So I left it like that. So this just cancels out. The square cancels out the square root, and this is just 2x plus 1. But this needs to be FOILed. So the square root of x plus 1 times the square root of x plus 1. This is x. This is 1 square root of x. This is 2 square root of x plus 1. So we have x plus 2 square root of x plus 1 when we FOIL that. Now what you do is you isolate this radical again. So we're going to move the rest of this stuff over so that the square root of x will be by itself. So to isolate this, we're going to subtract x. That leaves us with 1x. Subtract the 1, and that leaves us with 0. So I get x equals 2 times the square root of x. And at this point, I can go ahead and square both sides. I'll just leave the 2 there so that I'm not having to square x over 2 or 1/2 x. That's too complicated. I can square it like this, square this, and square this. This becomes x squared, and this becomes 4x. 2 square root of x times 2 square root of x is 4x. So now I set that equal to 0. And I solve. This is x squared minus 4x equals 0. So factor out the x, and it's x minus 4. And so my solutions are x equals 0 and x equals 4. And guess what I better do? I better check those one at a time. Check 0 and check 4. So let's start by checking 0. If this is 0, this is the square root of 1 minus 0 equals 1. That works. 0 is a solution. Let's try 4. So if x is 4, this is the square root of 9, and the square root of 4, that's 3 minus 4 is 1. That also works. We have 2 solutions. Both 0 and 4 are our 2 solutions for this equation. Now, fortunately for me, but not fortunately for you, I forgot to give you a lesson check earlier in this lesson when the problems were easier. That means this is your lesson check, you lucky things. So go through the steps that I just did. If you need to rewind and see again how I did it, feel free to do that. And see if you can solve for x, either one or both solutions or whatever, and bring that in for your lesson check for this section. And that's it. That was quite a lot in this section. And I went kind of fast because I knew we were coming to this difficult stuff, these difficult cases at the end. But that's how you solve basic radical equations. So good luck with that, and I'll see you guys next time.